Good morning, good afternoon, good evening, everybody. My name is Ian Miller from FatCloud, and I'd like to thank you very much for joining us today for this webinar on what if developing for hundreds of servers was as easy as developing for one. I'm joined today by Justin, who is our CTO, and he will handle half the presentation, and I will do an introduction to set the scene. The basic issue that we're seeking to address at FatCloud is making scale-out software development, deployment, and management easy, fast, and economical. The basic issue is that developing an enterprise piece of software for a scale-out environment is a complex, time-consuming, and somewhat fragile process, which we have set out to address by creating an integrated environment which makes scale and availability a very easy process. It's worth spending a minute before we get into the details of FatCloud itself to talk about how our industry has evolved over the last 2 or 3 decades. Many of you will recognize that we have come from an environment where we had mainframes or SMP Unix systems that were relatively expensive servers, but had the benefit of being relatively simple from a development paradigm point of view. They were a single entity with a single operating system and a single series of services that the developer could call on to make their program come to life. Today, the modern data center is actually populated by hundreds or thousands of small commodity servers. Today's data center is dominated by x86, or today x64, the 64-bit versions of those, in AMD or Intel-based servers. And in fact, 70% of server revenue worldwide today is populated by those kinds of servers. And in fact, 50% of all server revenue today is populated by Windows servers. But the fact is that scaling an application out across all of those machines, or a subset of those machines, is, as I said, a complicated and time-consuming task. It's no surprise, therefore, that people are attracted by the promise of the cloud, being a single service and having this concept of utility computing coming to life, whereby you don't need to personally be concerned about what's behind the plug, if you like, that you are connecting to. There's servers, there's storage, there's many devices back there, but you don't have to provision them, manage them, connect them, etc. It's done for you as a service. And so that vision of the cloud as the seamless entity that you can call on is very attractive. But the brutal truth of it is that behind that plug, there are still many servers that you have to figure out how to leverage. And the fact is that, again, programming to all of those machines and making an application work elegantly across them is not an easy thing. If I return to the analogy that I used before of the mainframe or Unix machine, scale-up development is relatively simple in that you have one operating system to concern yourself with. You have one database that you would call on from within your program, one file system, one job control language, work queue, scheduler type environment. And if you ran out of performance on your 4-processor Unix machine, for example, you would scale up to a bigger machine. Go to a 16 or a 32 or a 64 processor machine. And scale was therefore generally handled by hardware, in that you'd get more performance from the box and you'd scale up as the box scales up. However, the problem that we face in developing for commodity systems is that we actually have to architect a much more complicated series of functions as we subdivide how our application will work out across many entities in the data center. This chart that you see here is a subset of an application that was written a few years ago for a major media organization. And each of the boxes there is a server with a TCP address or an HTTP lookup, needed connection strings to get out to databases, etc. And it was a complicated, time-consuming project. And out of this project came the idea for FatCloud. The developers who did this system, when they had finished it, said, wouldn't it be great if instead of starting at line 1 of code and going through this tortuous design process, we could start with pre-built building blocks that would allow us to know that we were working on a foundation where we could trust the system to work and connect well together, and actually not even have to worry ourselves with the arcane issues of server addresses, lookup tables, connection strings, but have the environment take care of all of that for us. And out of that, FatCloud was born. And our vision for FatCloud was to provide this one series of services that the developer could call on and have the system take care of all of the connectivity and all of the issues that make a true application scale and have high availability. So let me just spend a minute in talking about the services that FatCloud delivers out of the box. The first is the core foundation, which is the bigger box at the bottom. And this is the series of services that FatCloud delivers that seamlessly integrate all of the nodes running FatCloud by doing self-discovery of all of the nodes running FatCloud, integrating them together so that, again, the developer doesn't need to concern themselves with specific IP addresses or any connectivity to the servers. It happens automatically. You then have access to a NoSQL key value store or database called FatDB. And FatDB is highly performant, very scalable, as well as you'll hear in a minute, able to deal with redundancy and high availability automatically through mirroring. There is a caching layer where you can cache not only your FatDB records for high-speed retrieval, but you can also connect out to legacy databases like SQL Server or Oracle and cache them within our caching layer as well. There is a work queue to handle asynchronous or batch jobs that would run through the system and will automatically manage the processing of those asynchronous tasks. And a file management system that actually breaks the limits of a standard Windows file system. We don't have a proprietary way of writing files. We do use the standard Windows NTFS file system itself. But whereas a standard Windows server can only see its C drive or D drive or any network attached storage it's connected to, with FatCloud, all of the nodes running FatCloud become available to the system. So if it's 100 nodes running FatCloud, all 100 disk systems are visible, and files can be written with available space managed as a large multi-node file allocation table. And finally, we have the Fat Apps area, which is where you would write your own business logic. And so as you look at it, and I make that analogy back to the mainframe or Unix era, where the mainframe had the one operating system, the one database, the one file system, the one job queue or job control language, and you look at FatCloud, you can see the analogy we're trying to make here. The developer can call on all of these services locally within the same layer that they're developing for, and they do not need to concern themselves with how many nodes will ultimately run FatCloud. It could be 1 node, it could be 10 nodes, it could be 100 nodes, but FatCloud will automatically connect to all of the systems that are required for scale, and it will also automatically manage the level of mirroring required to provide the level of high availability and redundancy the application actually requires. So from a paradigm point of view, the developer can treat this as one computer, but it can actually become tens or hundreds of machines without the developer having to do anything else. All the developer has to focus on is their business logic and the unique functionality they need to make their application come to life. And so just to return to these series of services, as I say, you can start with 1 node, and you can go to 2, 3, 4, 5, 50, 100, as your application actually requires. So you develop once and scale is taken care of. You can also develop once and mirror as many times as you want. Generally, we recommend, as you can see as this chart builds, going to 3 mirror layers for each node in an application. The reason being that you can lose one and still have one available mirrored node for redundancy. But each node is actually still fully participating in processing and I/O functionality. So even though the mirrors are providing high availability, they're not actually degrading performance or simply being a hot standby node waiting for something else to fail. They're actually active in the FatCloud environment. And so we actually get the best of both worlds. You get increased performance through these additional mirrored nodes, as well as high availability through a great deal of redundancy in the architecture. So that is what we're trying to achieve with FatCloud, providing a paradigm where you can deliver software much quicker because you don't have to worry about all of the computer connectivity issues and the high availability issues, and to allow those applications then to scale very easily based on the requirement of the application. One great example of this that I'd like to spend a minute on is Cricket Wireless. Cricket Wireless, as you I'm sure would be aware, is one of the major wireless operators in America that tended to focus on the prepaid calling card niche, and one that they did very well in. However, when the economic crisis hit in 2008 and 2009, a number of competitors came into their market, and they found they were losing subscribers based on just competing purely on the prepaid calling card service. And so they did an analysis of their customer base and identified the fact that over 50% of their customers did not have a computer at home, and so the only piece of technology they actually had was their cell phone or mobile phone device. And so they conceived of the idea of what became Move Music, which was a way to differentiate themselves in the highly competitive wireless space by allowing their subscribers, as part of their regular subscription fee, to download whatever songs or playlists they wanted into their mobile phone, and to therefore give them a great deal of additional value from their relationship with Cricket Wireless. It was a huge success. It was written in FatCloud, and it has now become one of the world's largest, if not the largest, streaming service of music available in America. It beat all of the targets that were set for it. They had a 1-year goal for subscribers that they achieved in 3 months, and they had a 3-year goal for subscribers that they achieved in 10 months. And if FatCloud hadn't easily allowed them to go from a few servers to 20 servers to 40 servers to 80 servers to 127 servers running in 2 data centers to 250 servers in total, then the application would have not succeeded in the eyes of the customer base. And so as it was, it scaled elegantly, and they never had to go and redesign the back end of their application, which FatCloud has managed now for over 18 months successfully. It is obviously a software as a service application, the Move Music project, and we're very proud to have been associated with the success of this application. So our value proposition, but very simply, is to develop fast, to allow you to get your application to market in up to 50% of the time it would take using traditional development methodologies or traditional .NET, while simultaneously, by scaling out and using these commodity microprocessor-based servers, allowing you to cut the costs of the total infrastructure required to deliver this kind of application by potentially as much as 2/3. In addition, you can scale effortlessly. Simply adding servers to your cluster or your cloud allows FatCloud to very elegantly give more performance and more scale to the application. And finally, you can run it wherever you need, whether that is in-house on your data center with no cloud infrastructure in place, or on a private cloud infrastructure in your data center, a public cloud hoster like AWS or Azure, or in a blend of those services. So that at a very high level is what FatCloud is all about. And I'm now very pleased to hand over to Justin Weiler, who is our CTO, who will take you through some questions and answers as to how FatCloud delivers many of the things I'm talking about.
Greetings. So I'm going to elaborate a lot on what Ian has already sort of led us through, and I'm going to answer or attempt to answer some basic questions. The architectural approaches that have been in the marketplace for quite some time, and some that are emerging, why FatCloud is different and how it makes developers so productive, why FatCloud has a major advantage as far as agility and pivoting goes. When you're creating an enterprise application, what are the ingredients that you need? No matter what enterprise application that you're talking about, it really boils down to some basics. What do we as a platform provide you to meet those needs? And really the question at the end of the day is why does FatCloud matter? Why should you care? So let's dive in. So here, this slide, what you're seeing is the typical three-tier architecture that is really commonly found in a lot of enterprises, where you have your web tier, a bunch of boxes, your business logic tier, another bunch of boxes, and your database tier. And the problems with this type of architecture is, are pretty substantial. First of all, you have to have some pretty beefy machines in order to handle it. And because these layers are, beefy machines, equates to spending a fair amount of money on hardware and licenses. Also, the thing that kind of is not so cool is that typically you'll have single points of failure, and you'll have hard-coded configuration values. So, for example, your business logic tier is going to be pointing to a SQL Server database. Hey, you know what? If that database goes down, you're kind of SOL. Also, you have to write lots of glue in order to get these layers to talk to each other. And in my mind, what I've seen, over the years is that you see those gray arrows in separating these tiers. That represents network latency, and it depending upon your use or lack of use of caching, you could potentially have a lot of network usage in order to retrieve your data, to store your data, et cetera, et cetera. So very typically, you can run into these bottlenecks that really sap your performance very quickly. And probably the biggest problem in this type of architecture is, if you remember the slide that Ian showed, let me see if I can go back to it. There we go. The problem. All of these interconnections between these layers and between these tiers involve a certain amount of, they're like TCP communications, HTTP, yada, 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 and they're all hard-coded configuration values. So I've seen instances where you have production servers pointing to staging databases, and you have some folks on your team utilizing web services. You have some folks on your team utilizing WCF or .NET Remoting 2.0 or whatever. It's a hodgepodge mishmash of techniques and strategies for interconnecting these assets. Now, hey, it's great to be able to mix and match and pick and choose. But you know what? At the end of the day, you're going to end up with a lot of different ways of communicating between, these various components. And from a sheer maintenance point of view, and from a pivoting point of view, that can be rather costly. And let me explain. So, 6 months into your development, business comes to you and says, hey, you know what? We have redefined exactly what our mission wants, what we want our mission to be. We need you to do X, Y, and Z instead of A, B, and C. If you've coded yourself into a corner by adopting a traditional architecture, you might find it really hard to pivot. Additionally, let's say that you have lots of scale problems. Your website's a huge resounding success, or your internal application's a huge success. It has way more usage than you'd ever figured, and you need to scale now. And that can be pretty difficult with a traditional three-tier architecture. So the industry understands this and has moved away from hardware-centric architectures and has focused more on cloud-centric architectures, with the primary reason that, hey, you know what? If you need to scale, it's right there for you. So there are no hard boundaries between, within the web tier, or the business logic tier, or the database tier. It's fairly economical. The machines or the instances are pretty cheap. It's a less of a configuration nightmare, less glue that you have to write, and things tend to be a lot more robust. But a couple of problems still remain. One is that you're still prone to bottlenecks. Your performance is really going to depend on how well your business logic tier and how well your database tier is able to serve up and process data. You still have those gray arrows in between these tiers, and that represents network latency. That can be a little costly. Also, the fact that you have these discrete tiers means that it potentially can be still be hard to pivot or change your business mission. And the other thing that is kind of not really talked about in these cloud offerings is that having an SOA with discrete software services may or may not be scalable. It really depends on how they're implemented and what your business needs are. It is not true that you can just add infinite instances and achieve scale. If there is coupling going on or state going on, which is basically any non-trivial enterprise application, you really have to consider where that coupling is, where that state is maintained, and whether or not your discrete layers are up to the task. There are some hosters out there that have performance limitations on what you can achieve using their infrastructure. Their performance limitations become your performance limitations. And finally, one of the things that can be significant is that you're giving up control. Not only are you giving up control over where your data is and any security implications of such, but you're giving up control over the implementation of the layers and your coding to particular solutions. So the cloud-centric way of doing things is definitely a step in the right direction. It's a good evolution, but we've taken it a step further, and let me explain. FatCloud-centric, a low-tier architecture. Now, what do I mean by low tiers? Well, it's pretty much as simple as this. Any discrete tier is going to involve a certain amount of latency. Transit from one tier to another means that you are going to incur a network hop. This can certainly add up for very high throughput applications. So why is a low tier architecture important? We still get the economical scale out architecture. There's minimal configuration, minimal glue, less points of failure, avoids the performance bottlenecks that we were talking about. It's much easier to pivot and expand your capacity, and your performance benefits are truly built in, and you can truly scale out. Most importantly is that you keep your control over your cloud, and you retain your options. Now, I know a lot of this sounds rather, pie in the sky and amorphic. Let me try to make it more concrete. So how would you do a typical three-tier architecture with FatCloud? Well, it would look like this: 3 tiers. Essentially, you have your web tier talking to your business logic layer and talking to your NoSQL database backend. And you see, the 2 sets of arrows. We have not gained anything as far as network latency here. But using the FatCloud architecture, you can turn it into more of a low-tier scenario, where what you're doing is you're clustering your business logic and your database. Because we are an integrated solution, we allow you to do that, which is a fantastic value add. So what that means is that you can group all your business modules with your data, not something that you can typically do with other NoSQL databases and whatnot. We are integrated, so all of your business logic runs as first-class FatCloud citizens, and it uses the same consistent routing algorithm and same plumbing that our NoSQL database uses. Why is this important? Well, you see only a single set of arrows. You've just reduced your network latency by a hop, and you've clustered. And it's a lot more because you've clustered your logic with your data, and you can process your data right where it lives. That's a phenomenal performance increase. I've just shown you scenario A and scenario B, which are super easy to do with FatCloud. You want to use scenario A, have at it. You're going to be no better and no worse than any other cloud-enabled application platform out there. But if you want to start taking advantage of data locality and the clustering of missions, you absolutely can do that with FatCloud very easily. So that's just one sort of very traditional example of why FatCloud can really be beneficial, because you have options. Now, let's just talk about enterprise application development in general and the kind of things that you need. Well, if you boil it down to its most basic components, you need to store and retrieve data. You need to store and retrieve files. You need to process synchronous requests. You need to process asynchronous jobs. And at the end of the day, you need to maintain the thing. Those basic functional requirements are pretty true in most any enterprise application. You can, you essentially, of course, build upon it, but those are the fundamentals. Now, non-functionally, what you also need, you need a consistent metaphor. You can't have that previous diagram, with all the, interconnections and spaghetti, spaghetti architecture. If you don't have a consistent metaphor, maintaining the thing and pivoting is going to be impossible. You need it to be reliable. You need it to be scalable. You need it to be flexible. You need to be able to extend it and mold it and shape it how you wish, because you will get situations where you're going to have to pivot, either for a business reason or for a scale reason. There are things that you will know 6 months after inception of your architecture that you had no idea of. So it behooves any solution that you choose to be flexible and extensible. And by extensible is, you want to put your business logic right where right where you need it, essentially. You know what? There are a lot of folks out there that advocate a la carte approach to these things. They're like, well, you want to choose the best solution for each component, and we're going to choose a NoSQL database from this person or this company. We're going to choose a message queue from that company. We're going to, write our business logic here, a custom solution there, et cetera. Very decoupled, very, very a la carte approach. The problem with an a la carte approach like that is that you have to write all the glue required to integrate these components, and there will likely be impedance mismatches. Plus, you don't get the benefit of having a simple paradigm and a cohesive, uniform way of doing things. That's one of the differentiating factors about FatCloud, is that it makes your developers more productive because it's a consistent paradigm. It's a known quantity. You don't have to deal with disparate pieces of technology and knit them together. I would argue that at the end of the day, the productivity with and it doesn't have to be FatCloud, but the productivity of a integrated environment far exceeds that of stitching together disparate components, and it's a pretty big one. And of course, the last non-functional requirement is performance. And hey, if it doesn't perform, then you know what? You're not doing so well. So what do you get with FatCloud that addresses all of these concerns? To store and retrieve data, we have FatDB as well as FatCache as far as the caching end of it. They're very similar and share a lot of the same functionality. To store and retrieve files and assets, we have the Fat File Management System. To process your synchronous requests, we have the Fat Apps, which is your business logic. If you're a WCF developer and you use the service contracts, data contracts, the only thing additional that you're doing is you're deriving from some base classes and choosing some FatCloud strategies. It's super simple. You need to process asynchronous jobs. That is your Fat Work Queue plus your Fat processors. And to maintain the thing, we provide the Fat Admin. Now, to satisfy the non-functional requirements, being consistent, reliable, scalable, flexible, extensible, and performant, that is really the purview of the FatCloud core. And essentially, it gives you a uniform solution for routing and handling scale and reliability and being able to extend your business mission. So if you want to develop fast, if you want to basically reduce not only your short-term expenditures but your long-term expenditures, well, how does it do it? How does it accomplish this? Well, you have the basic paradigm of cloud computing, which revolves around commodity boxes. But you also have less developer expenditures. You have less pain that you're going to have to incur when you're pivoting. Maintenance is easier. Time is money. Essentially, is what I'm trying to say here. And reducing risk and peace of mind. This is a battle-proven solution that absolutely has delivered and will deliver for you. And most importantly, you retain options. You can run your stuff up in a public hoster. You can run it on your private machines. You don't have to change when you change, physical locations. You don't have to change much of your architecture when you pivot. One of the things that we like to say is you can change everything without having to change much of anything, and that is the FatCloud. One of the FatCloud credos. We were written by developers for developers. We know we have experienced the pain. We've done this for many years. We know where the performance bottlenecks are, et cetera. And if we can save you some of this pain, then we've done our job. Because enterprise application development is tricky. It can be very difficult, and it doesn't have to be though. So if we can deliver that to you, then we've won. And when you win, we win, and that's what we like.
Thank you, Justin. I'd like to now open it up to any questions. If you have a question to ask, please click the Raise the Hand button in your GoToWebinar window, and we will unmute you, but please feel free to ask any questions if you have any. Okay, we're not seeing any questions yet. We'll just give it another minute. Hello. If you could ask your question, that would be great. Is that Janine? Do you have a question?
Hi. Can you hear me?
Yes, we can hear you.
I guess, wanted to know, experience with different hosting your application on different platforms. What have you seen as successful? What have you seen as, I guess, your feedback on
that? By different platforms, you meaning like
infrastructure?
Yeah. Well, here's one of the if we're talking private cloud, one of the things that we've seen is we recommend a certain commodity box profile. As an example, one of our benchmarks is 4 processors, 8 GB of RAM, and a reasonably fast hard disk. That sort of gets us into a good ballpark for a general workhorse. Over the years, the capabilities of these machines have increased quite a bit, and that's likely the low end. We currently have a limitation of several hundred boxes in the same UDP multicast environment. So if you were to go beyond several hundred boxes in a single environment, we would recommend doing some other things. But it really depends on how you architect your FatCloud solution. You certainly want to follow best practices and keep your data where your processing is, etc. Now, if we're talking about like an Azure or an EC2 type of experience, we definitely run on Azure and EC2. We have a different way of self-discovery aside from UDP multicast that allows these instances to talk to each other. And again, it really depends on your which type of which size instance that you run on. It's the kind of thing that you have to test out. Of course, a private framework is going to be more performant than running on a public hoster. But the great thing about FatCloud is that you don't have to be tied into their data storage mechanisms or any of their SOA that you don't want. You can use their SOA, or you can use FatCloud. And with FatCloud, it's far more consistent across different environments. So it's the kind of thing I always like to tell people: POC it. You know what? Do your tests, find out what works for you, and find out what you need. The only way to really be able to tell is to do the experiment.
But just to amplify with that, we also run very happily on other public cloud environments, and we partner with companies out there like SoftLayer and iNetU and other companies as well. So we're very happy to work with whatever public hoster a customer would actually want. Let me move ahead now to another question. This is from a person whose mic is not working, who's asked the question: is your technology is your solution technology agnostic? How do you differentiate with other solutions available in the market? I think that's an excellent question. And let me break it down into two parts. Is our solution technology agnostic, first of all? We are committed to .NET, and so we are very much based on the Microsoft ecosystem. And so in that sense, we are focused. On the other hand, we are able to integrate multiple third-party elements into a FatCloud solution. I mentioned earlier, for example, that we can cache SQL Server or other databases using our FatCache capability, but we can also fully embrace and integrate other database technology into a FatCloud solution. If you think of FatCloud as a turbocharged .NET, if you can do it in .NET, you can do it in FatCloud. But what you do when you do it in FatCloud is you add that ability to locally, in your tier of computing, have access to your own database, our FatDB NoSQL database, the file management system, the work queue, and the other functions we've talked about in this webinar. And so the differentiation against other products out there is that tight integration. Rather than going out and having to yourself take responsibility to plumb a third-party database, a work queue, a file system, and figure out how to make your architecture hang together in a way that scales elegantly, with FatCloud you can just focus on your business logic. Focus on what makes your application unique, and FatCloud will actually deal with the scaling, with the high availability, without you having to concern yourself as a developer with those particular functions. And as we've looked at other products in the marketplace, we haven't found any other product that delivers the integrated functionality of FatCloud. There are certainly products out there that are .NET focused, and there are certainly products that offer, for example, a platform as a service type function on the cloud. But when you get to those services, you find standard .NET. There is no turbocharging, there is no integration, and so it is that speed of development and elegance of scale and high availability which really differentiates FatCloud. Are there any other questions? Okay, well with that, I would like to thank you all very much for attending. I would like to thank Justin for presenting. And obviously, if you have any follow-up questions, please feel free to reach out to us. And of course, our website has a lot of supporting material on www.fatcloud.com.